Here is an excellent example which will throw a lot of light on solving systems of equations and understanding their solutions. Vectors 9.4. Analyze row echelon form. Using Gaussian elimination, we have obtained the solutions for the intersection of three planes for two different systems in row echelon form. So these are the solutions of the two different systems which you need to analyze. Explain how these two systems are different. So have a good look at these two systems. It seems to be very similar, except for a major difference, which is in row 3. You see 0 equals to 0 here and 0 equals to 1 on the other side. Now, how do you say that the systems are different, right? So this is what you need to explain. Now, as we see here, we get 0 equals to 0, which is always true, right? This is always true, right? It's always true. But here we get 0 equals to 1, which is never true. That means this system is consistent. And this system is not consistent, right? Now, what could the systems be? So one possibility is that since we get here 0 is not equal to 0, it suggests that the two planes could be parallel, right? And the third one is intersecting them in a line, right? So it could be like this. This system could be like this. Like this is one plane, and let us say the second plane is here parallel to this plane. Correct? And the third plane could be intersecting them in two separate lines. For example, let's say this is my third plane. Okay, let me just draw like this. This was not a good drawing anyway. Let's say this is the line of intersection for the first plane, and this is the line of intersection for the second plane, and that is the line which I want to draw, right? This is the line which I'm drawing. So that is how the situation could be. So it represents that the two planes are parallel. These are the two planes, let me say pi 1 and pi 3 are parallel. That means this is, let's say pi 1, this is pi 3. And the second plane, in this case this is pi 2, intersects both of them. That could be the situation, right? Now here the situation could be that we have two planes which are overlapping, exactly same planes, right? So these two planes are, let us say this plane is different for me now. Let me use a different ink. They are overlapping, right? They're exactly kind of same. I should have made closer, but they're overlapping. So what I'm trying to show here is that the third plane intersects this in a line. And that is the common line between the two, right? Think that this gap is not there. I've shown the gap to you so that, just for clarity, right? At times when we make things very clear, they don't look right. Anyway, so that is how the situation is, right? So that could be the case. Now, you could also write probable equations for these planes. For example, the equation for this plane could be x minus 3y plus z equals to 2. And this plane, we could have a scalar multiple of this. So it is, let's say, 2x minus 6y plus 2z equals to 4. In this case, if I write the equation, then it becomes like x minus 3y plus z equals to 2. And in this case, if I multiply this by 2, I get 2x minus 3y plus 2z equals to, now this is 1 more than 2. Do you see that? It is not 2. So when you want, it's not 4. It is 1 more than 4. It is like 5. Do you understand? So if I do 2 times this minus this, I get 1 here. Now that 5 makes the whole difference. So that means that the planes are not exactly same. Do you understand? And the third plane is, in this case, well, we can derive the equation of the third plane by another operation, which could be, let's do it. So that is, we eliminated 1 from here, so we could just add this equation to this equation to get the equation of this plane. So when we add this, we get x here, minus 3 plus 1 is minus 2, y, 1 minus 1 is 0. So that is 0 component for us is equal to, when we add this, we get 1. Do you see? So that could be the possible equations. Let me write here, x minus 2y equals to 1. So we could have this kind of system of equations for them, and you see the major difference is that since these two planes are parallel, they intersect at 2 different lines with the third plane, right? In this case, they're exactly same planes. So what we have here is pi 1 and pi 3 are same, are exactly same planes, right? As you can see from the equations, correct? So that is how we explain these solutions. I hope it's absolutely clear to you. Thank you.